already to the last stretch of our semester. So our objective for today, I can solve and graph quadratic equations. Read together, 1, 2, 3.
I can solve and graph quadratic equations.
All right, so we arrived now to where we wrap up everything that we've learned all year. So hopefully this will kick in. You're going to see how everything kind of like meshes together. You're going to need to trust the practice that you have in your noodle already with all the home play that you've done, and you're going to see how it's all going to kick in. So quadratic equations, what are they? Quadratic equations are two variable equations where the highest degree is 2. Hopefully you understand every word on that definition by now. Two variable equations where the highest degree is 2. Examples: x squared plus 3x plus 2 equals y, x squared minus 9 equals y, y minus 6 equals 3x squared minus 11x. Copy that. You got 40 seconds. Go. Okay, so let's see if the definition makes sense with the example. So there's two variable equations. Let's see. Is this a two variable equation? Yeah. Y and x, x and y and x. All of them are two variable equations. The highest degree of the whole equation is 2. Let's find out. Look at this one. What is the highest degree? To the second, to the second, and to the second. Okay. So it makes sense. These are quadratic equations. Let me show you what are not quadratic equations. Copy this. As you're copying those, start thinking, these are not quadratic equations because blah, 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 blah. So these two and that one, copy that, please. All right, tell your neighbor why these are not quadratic equations, please.
The first one is the last one before one variable. Second one. So the first one, the third one doesn't have a y. The second one is not equation.
Nice. All right, let's see. Marco, why are these two not quadratic equations? They don't have the equal sign, so what can we call them? Thank you, Marco. Expressions. All right, how about this one right here? Why is this one not a quadratic equation? Sophia? There's only one variable, that's one thing. What else? Pedro? Highest degree is not 2. What is the highest degree? 1. Therefore, what would be the name for this one? Okay. That is correct. Linear equation. Yeah, Pedro, you're in a row. Get it? In a row? Like honor roll? Honor roll? Honor roll. Cabano. Anyways, come up with a couple of hashtags. What makes quadratic equations quadratic equations? Keep it to yourself for right now. Right, at least 2 of them. Hashtag what, Cooper? 2 variables. Pass someone. Andrew? To the second degree. Do you agree? All right. So yeah, I'll take those 2. Also, some of you might have written equations only. Yes. Equal signs or something like that. Okay. So hashtag equal signs.
Hashtag honor roll.
And no. All right. So steps. You're going to come up with the steps as I go through the process, and right next to the example, you're going to come up with that. Okay. So here we go. Turn your paper over. You're going to need the whole paper space for that. So at the top, I want you to write example 1. Solve the quadratic equation by factoring. Check your answer. Equation given, x squared plus 8 equals y plus 6x. Copy that, and then I'll go over the process. All right, writing utensils down, please. Please focus on this one. You're going to be doing all the thinking. I'm going to show you the process, but by now, you have all the processes already in your noodle. You should be able to articulate in words what the step is, and then from there, you need to understand every step. Okay? So here we go. Write your utensils down, look up to the screen. It says, solve the quadratic equation by factoring. All those words should sound familiar by now. We know how to solve equations, we know how to factor, we know how to check our answer, but now it's putting everything together. Okay? So here we go. Step 1. And right now you're just paying attention. Ready? Here it goes. What I just did right here, it gives me 2 things that need to be true for step 1. 2 things. Think about it. What 2 things need to be true because of the step that I just did for step 1? What 2 things are true so far? Talk it over to your neighbor. What 2 things need to be true? Nice. Okay. Who's got one of the items that needs to be true for this step? Octavio.
The y variable needs to be isolated.
So isolate y. That is correct. So you're not copying yet. I just want to get this down first. That's one thing. Okay? So yeah, y is isolated. What is the second thing that needs to be true? Up to right there. Who's got the second thing? We've been doing this. Jessica? That is correct. Standard form. Copy that step and write step number 1 next to it. Those are the 2 things that we just did. Number 1, isolated the y or solve for y. And then it needs to be in what? Standard form. And you should be understanding all this by now, yes? Okay, good. Copy that. Now I'm going to change to red, step number 2. Writing utensils down, look up to the screen. You'll finish copying in a little bit. Step 2. To do step 2, it's important because the whole thing for this problem is to solve. So, did we already solve quadratic functions? Yes. We solved quadratic functions by graphing. So, there was a question at the end that we answered. The solution to a quadratic function is or are what? Talk it over to your neighbor. What were the solutions to the quadratic function?
Wait, no. Not that. I have to write it down.
Okay, let's see. Better, you think you got it? Okay, go. That is correct. The x-intercepts. When we graph the quadratic function, the x-intercepts are our solution. Now, before writing anything down, if we plot the x-intercepts, what is the value of y for those intercepts? Tell your neighbor, what is the value of y when we have x-intercepts? Everyone. That is correct. That's why step 2, in order for me to solve or to find the solutions or the roots of the x-intercepts, y needs to be what? 0. X squared minus 6x plus 8. So what would I call this step? Substitute 0 for y. That is correct. Write that down. Substitute 0 for y. I'm going to change to black, and that's step 3. Okay. So step 3 is a little bit more lengthy, so I need you guys to stay focused till I finish, and then I'll let you know what to copy. So write any utensils down, look up to the screen. Here it goes. So it said, solve the quadratic equation by factoring and check your answer. So the first thing we did is isolate the y, or solve for y, and make sure it's in standard form. Did we do that? Yes. From there we substitute 0 for y. Yes, because when we solve the quadratic function to find the x-intercepts, the y has to be 0. Okay, so there it is. Step 3. Pay attention, please. Here it goes. So, in one word, tell your neighbor, what would all this be called in one word? That is correct. Factor. Step 3, factor. Copy that, please. Well, the process, like I did a lot of stuff for only one step. Copy that. Step 4, I'm going to switch to green. Step 4. Yes? I'll let you know later. Okay, here we go. Writing utensils down, look up to the screen. You'll finish copying in a little bit. In order for me to do step 4, I need to revisit a property that we covered at the beginning of the school year. So just to revisit. At the beginning of the school year, I remember that we started with additive inverse property. Remember that? And then we did identity property of addition, which was using 0 pairs to solve equations, stuff like that. But then I said, when we got into multiplication, I said, any number times 0 is 0. And I said, we're going to revisit that property later on. Even though it's a very simple property, we're going to revisit that. Now we're here. That property is called 0 product property. Tell you what it's called. 0 product property. So 0 because it's 0, product because it's multiplication, and it's a property. So in order to make that short and not write the whole thing, I'm going to write it as ZPP. You down with ZPP? Yeah, you know me. All right, so check this out. So what does 0 product property say? So don't write this down, just pay attention. 0 product property says, check this out. A times 0 is what? 0 times B is A times B is 0. What could A be? Or what could B be? 0. So what I just showed you, up to the ones I want to focus on is these two right here. A times B is 0. That means that A could be 0 or B could be 0. Yes? All right. So that is not part of this problem. I'm just showing you the property at work. So now that we established that, let me go to the step. Step 4. Look up, please. X minus 2 times x minus 4 is 0. Or in other words, this times this is 0. So what could this be? What could this be? So what could I write here, Luker? That is correct. That is a zero product property. Copy that, please. Let's go. Luker from the corner. Wow, be nice. Be nice. All right. That was step 4. Okay, any questions as to why we wrote this? We're good, right? Okay. Step 5, I'm going to go back to color blue again. Step 5. For step 5, our brain, with all the work that we have in it, automatically wants to do stuff with this. What shall I do here? Plus 2 plus 2, x equals 2. How about here? X equals 4. These are my solutions. X intercepts, zeros, or roots. So that was step 5. What would we call step 5, everyone?
Anything you want to
Solve. And specifically solve for x. That is correct. Copy that. And notice how your brain already is starting to do the work by itself, right? Number 6. Nope. Okay, writing utensils down. Here we go. You'll finish copying in a little bit. All right. Hold on. You're just paying attention right now. Okay, so step 6 is graph. Before you copy it, though, pay attention, please. If I was to give you the equation, y equals 3x plus 2, tell your neighbor the y-intercept of that one. 2 is correct. What if I gave you the equation y equals negative 6x plus 8? What is the y-intercept for that one? 8. So specifically, why are these the y-intercepts? What's the name of these two? The other ones have variables. What are these called? Constants. That is correct. That's how I know that they are my y-intercept, because they're constants. Now let me go back to the previous one. Look at this equation. Look up. What is my y-intercept? 8, because it's the constant. That's why I placed the 8 right there. You can also multiply the roots. Yes. Copy that, please. That's the graph. Number 7. Yeah, I know. I'm waiting for you guys to copy that, and then we're going to go to step 7. Yeah, it's close. Yeah, so for 7, it's going to be our check. So I'm going to zoom in. And I'm going to write my equation here. X squared minus 6x plus 8 equals y. X squared minus 6x plus 8 equals y. Why do I write it twice? There's two solutions. What is the first value that I'm going to substitute in here? 2 squared minus 6 times 2 plus 8. And when the solution is the x-intercept, what is the value of y? 0. That is correct. What do I substitute for this one? 4 squared minus 6 times 4 plus 8 equal to 0. Let's see if it's true. What is 2 squared? 4. Negative 6 times 2, that's negative 12 plus 8 equals 0. Combine like terms. What is 4 plus 8? Minus 12 is 0 equal to 0? Yes. 4 squared is 16. What is negative 6 times 4? Negative 24. Bring down the 8 equal to 0. Combine like terms. What is 16 plus 8? Minus 24. 0 equals 0. And that is true. And that's how we check. I'm not. I'm a mathematician. Let's see. Let's look at the whole process. Let's see if we got it. Step 1 was to isolate y, or solve for y, and set it in standard form. Did we do that? Step 2, we need to substitute 0 for y. Why? Because we're solving, and that means that the y value has to be 0. Step 3, factor. We know all the process by now, by heart, and we stop right there. Step 4, ZPP. Yeah, you know me. So then we set each one of these equal to 0. Step 5, we solve for x. They're known as what? Solutions, x-intercepts, zeros, and roots. Step number 6, we graph. What do we use to graph? The intercepts, the x-intercept and the y-intercept. And lastly, we check. A lot of points. It's a lot of points because this has all the processes. Now, check this out. The majority of you follow along really well, and you're going to be doing well with this next one because it's already in here. Why? Because that's how it pays off to do your home play. So with that said, I'm going to give you this next one, example number 2. Without looking at the process, I want you to try to do the whole thing minus the check. But right now, we're not going to do the check, but I want you to do the whole thing up to the graph. See if you can do that by yourself. Ready? Here we go. Example 2. Here it goes. Example 2. We have y minus 7x equals x squared plus 10. Example 2. Y minus 7x equals x squared plus 10. Copy that and go. Once again. You don't have to write the steps on the side, but see if you can do the entire process by memory. Ready? Go. Okay, here goes the process. Line down the equal sign. Plus 7x plus 7x. Y equals x squared plus 7x plus 10. From there, substitute y for 0. X squared plus 7x plus 10. From there, 10 is our product. 7 is our sum. Therefore, it's 2 and 5. From there, 0 equals x squared plus 2x plus 5x plus 10. Group. GCF here is x. We're left with x plus 2. GCF here is 5. We're left with x plus 2. 0 equals x plus 2 times x plus 5. From there, ZPP, x plus 2 equals 0. X plus 5 equals 0. From there, I solve. Minus 2 minus 2. X equals negative 2. Minus 5 minus 5. X equals negative 5. These are my solutions. X-intercepts, zeros, also known as roots. Yes, you need to write all 4 of them. Why? Because I want you guys to remember the names of them. Next, graph. Negative 2 goes right third. Negative 5 goes right there. And my constant on the equation is 10, which is up here. And we're going from left to right. Hands if you got that. Let's go. Show me the single shots up through you are with these. Okay, 5 4s, 5 4s, all right. 3s, all right. All right, check this out. Writing utensils down, look up to the screen. Now, what if I gave you this one? Look up. They already have it in Y form and in standard form. Next step, equal to what? 0 equals 2x squared plus 5x plus 3. What number goes on top? 6. Remember that? And 5 goes down here. Factors are 2 and 3. That's 5, and so on. And you know what to do from there, yes? Now check this out. The whole plate is going to have also some that look like this. Let me zoom in. Okay. But in the examples, when we started with functions, what did I say? That this replaces what variable? Okay, here it goes again. This replaces what variable? Y. Okay. But since, notice that over here they already did a bunch of work for us on the right side, so it's no longer Y. What should we change this into? 0 equals x minus 7 times x plus 2. What is my next step? ZPP, yeah, you know me, x minus 7 equal to 0, x plus 2 equal to 0, plus 7 plus 7, x equals 7, minus 2 minus 2, x equals negative 2. These are my solutions. X-intercepts, zeros, and roots. Now check this out. This is where I wanted to get to. Don't say it out loud. Keep it to yourself. Is that crooked? A little bit, right? Okay, there it is. The other one, that's fine. All right. So this is 7. The other one is negative 2. But wait, we don't have a standard form equation. Tell your neighbor the y-intercept for this one. Ethan, go. So, negative 14 is correct. Let's find out. Look up. Look at this previous one. Hold on. Look at the one you just did by yourself. If I give you just a graph, these are my roots, this is my y-intercept. What shall we do with these? Look at these. So therefore, what is negative 2 times 7? Negative 14, going from left to right. Okay, we got it? Hopefully for tonight. Page 577. There is tutoring. Hold on. And then you're doing numbers 11 through 23. I want all of them done and shown with graph. You don't have to check them. But I want the entire process for all of them. Have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.